I want to talk about the history of complex numbers and the people behind the discovery of these numbers. So a complex number is a number which has both a real number, which is 1, 2, 3, 4, 5, and an imaginary number. An imaginary number is a number which contains the square root of -1. Now, we'd have come across these first when we talk about quadratic equations. And a quadratic equation is an equation where the highest power of x is 2, so x squared. And we have a formula for solving quadratic equations. But in the past, when you use this formula, you could easily get a negative number under the square root. And what people did in the past, when they got a square root of a negative number, they would say that this equation did not have a solution. But we now know that it does have a solution, but it's just called a complex solution. But the actual history of complex numbers more comes from the discovery of trying to find a formula, similar formula for the quadratics, but for cubic equations. Now, a cubic equation is an equation where the highest power of x is 3, so x cubed. And it started in Italy around 1500 when a mathematician called Scipione del Ferro came up with the solution. He came up with a formula for solving cubics. They were actually called depressed cubics. Now, that's not a sad equation. That is an equation which doesn't have an x squared part of it. So it has an x cubed, but it doesn't have an x squared term. And that's just a little bit easier to find a solution for. And if he was alive today, he would have published that in a mathematical journal, or he would have gone to the press, and he would become very famous. But at this time, what you would do is you'd hold on to this information because you could use it to your advantage to get a promotion or to get more pay. Del Ferro held on to this information until just before he died. He died in 1526, and he passed it on to his student Antonio Fore. Fore became famous for being able to solve cubic equations. But in 1535, he challenged another mathematician, Niccolò Fontana, who is better known as Tartaglia, because when he was younger, he was struck in the face by a French soldier with a saber, and that left him with a stammer. So Tartaglia means stammer in Italian. So Fore challenged Tartaglia to a mathematical duel. Now, a mathematical duel isn't like a normal duel with guns. A mathematical duel is where both opponents, they pose 30 questions to the other person, and then they're given 40 days to solve these equations. So Tartaglia realized that Fore must have some information because he was very confident that he could solve these equations. So Tartaglia did his own homework and came up with a solution just before the duel of how to solve cubic equations. So when the duel actually happened, Tartaglia solved all of Fore's questions in 2 hours, and Fore could not answer any of Tartaglia's. So now Tartaglia became famous around Italy for being able to solve cubic equations. But another mathematician and a doctor, Giuliano Cardano, wanted to get this information for Tartaglia. And Tartaglia didn't want to give this information to anyone. But in 1539, Cardano persuaded Tartaglia to come to Milan in the promise that he might be able to introduce him to a benefactor that could get him a better paid job. Tartaglia came to Milan, and at that time, after being pestered by Cardano for so long, Tartaglia decided to give Cardano the solution or the formula for solving cubic equations. But Cardano had to promise that he wouldn't tell anyone. So Cardano, the only person that Cardano told was his student Ferrari, and Ferrari and Cardano actually went along and took the Tartaglia's solution and actually improved on it. But they couldn't publish it because Cardano had made that promise. But in 1543, Cardano actually spoke to Del Ferro's family. Remember, Scipione del Ferro discovered this formula first in 1500. So he spoke to his family and realized that Del Ferro was the original discoverer of the formula. So he thought it would be okay to publish this information, so he published it in 1543 in his book Ars Magna. In it, though, he did say that Del Ferro had come up with it as well as Tartaglia independently. Tartaglia was not at all happy, and he went to told all the Italian mathematicians of the day that this was his work and that Cardano had broken his promise. It was down to Cardano's student Ferrari to actually defend Cardano's honour. And what happened was that Ferrari and Tartaglia had a duel in 1548. The duel happened because Tartaglia wanted to get a position in a university, and he couldn't get this position in the university unless he actually had the duel with Ferrari. Tartaglia realised, though, even on the first day of the competition, that that Ferrari could solve these equations better than he could, so he walked off in shame. The actual formula for solving a cubic equation is called Cardano's method, even though it was discovered by both Del Ferro and Tartaglia before him. Now, when you solve cubic equations, so let's take this example of a cubic equation, x cubed is equal to 15x plus 4. When you try and solve this cubic equation using Cardano's formula, you end up getting a square root of a negative number. And Cardano was very uncomfortable with it. He didn't know how to proceed when you get the square root of a negative number. But in 1579, an engineer called Raphael Bombelli decided to just accept the square root of -1 as a number. And if you do that, you can actually come out with the solution that you need. So if you take this equation itself, x cubed is equal to 15x plus 4. Now here's a graph of the equation. And you can see that it does go through the x-axis. So it must have one real root. You should be able to use the formula to get that one real root. But if you accept that square root of -1 is a number, you can actually get the answer that you need. So he used and he understood, he came up with the mathematics to use the square root of -1. About 100 years later, in 1637, Rene Descartes, who was using imaginary numbers at the time, was not very happy with them, and he gave them a sort of a derogatory name. He called them imaginary numbers, as if they didn't exist. So an imaginary number is a number. It's just that it does not appear on the real number line, but it is a number that does exist. 100 years after that, in 1750, Euler, a famous mathematician, he decided to introduce I as a symbol for the square root of -1. And then in 1796, the prince of mathematics, Gauss, came up with what's called a complex number. A complex number is where you have both a real part and an imaginary part. Now these numbers are so useful today in engineering, in science, that it's very important to understand the basics of it. But here we just wanted to give you an idea of the background behind the history of these amazing numbers.